Hello, in this video we will now look into the qualitative variables. We would like to model these qualitative variables and include them in the choice model, and we will see how to do that. In many circumstances they influence the choice a lot. So in the context of transportation mode choice, for example, we can think of the comfort of the train. We can think about the reliability of the bus. If you are interested in marketing, if you want to know how people choose one item or the next, it may depend on the shape or the color of the box, and so on. So all these concepts are qualitative, but they are very important, so we need to be able to include them into the model. In order to see how to model a qualitative variable, let's take the example of comfort. So we consider the variable comfort. The first thing to do is to identify all possible levels that this variable can take. So we consider it as a discrete variable. In this example, we can consider 4 levels: very comfortable, comfortable, weather comfortable, and not comfortable. Once we have identified these levels, we need to select one level which is considered as the reference. We call it the base level. In this example, let's consider very comfortable as the base level. Now we need to make the mathematical modeling of this variable. To do this, we introduce an attribute, which is a binary variable, binary meaning that it can take the value 0 or 1, for all the levels except for the base case. So in this case, in the example of the comfort, we had 4 levels. We took very comfortable as a base case. So we include ZC for comfortable, ZRC for rather comfortable, and ZNC for comfortable. And we associate with this variable a coding convention. This coding convention is reported in the table on the right. When all the variables are 0, well, it means that it corresponds to the base case, very comfortable. And when one of these variables is 1, then it means that the qualitative variable is associated with the corresponding level. So if ZC is 1, it means that we are referring to comfortable. If it is ZRC, it means that we are referring to rather comfortable. And if it is ZNC, it means that we are referring to not comfortable. So in general, if a qualitative attribute has k levels, then we introduce k-1 binary variables in the model. After we have defined these binary variables, well, we can include them in the utility function exactly as we did with the quantitative variables. So in this example, the utility function will be defined as beta c times zc plus beta rc times zrc plus beta nc times znc. Note that the choice of the base level is arbitrary. And I let you do as an exercise the comparison of a model where you normalize the very comfortable level with another model where you would normalize, for example, the comfortable level as a base case. They are equivalent, and this can be verified easily. In terms of socioeconomic characteristics, there are also plenty of them who are qualitative. Sex, education, professional status, and so on are qualitative variables. So we need to be able to model them in the same way as we did for the attribute. So as we did before, the beta coefficient now would vary across individual. In the continuous case, we took the example that beta 1 would vary with income, which was a continuous variable. Here we would like to model the fact that beta 1 may vary across education level, for example, the level of education. How do we do that? This is called segmentation. So we assume that there are k levels for the qualitative variable. So let's say education, we have like 3 levels of education, and each level is associated with a segment in the population. And what is important is that for each individual, we need to identify which segment they belong to. So segmentation is a partition of the population. Each individual should belong to exactly one segment. Based on this segmentation, we can now define binary variables that I denote here by delta kn, which is equal to 1 if individual n belongs to segment k, and 0 otherwise. And now what we do is that we introduce a different coefficient, a different parameters, beta 1k, for each level, for each segment in the population. And now, the beta 1n that we would like to include in our specification can be written as the sum over all levels of beta 1k times delta kn. And because each individual belongs to exactly one segment, this sum will include only one non-zero term. So basically, this sum will pick the beta which correspond to the segment and include it in the utility function. So we have the first specification, beta 1n zin. We replace beta in now by the sum that we have defined, and we obtain this specification. And like we did before for the quantitative attributes, we interpret this specification as the definition of a new variable. So we define a new variable xin, which is the product of delta kn and zin. So basically, xin will be equal to zin for individuals who belong to the segment k, and will be 0 for all other individuals. And therefore, this segmentation can be written as a classical linear in parameter specification. And clearly, you can generalize this with more than one variable. So let's take this example where I consider that people behave differently depending on their gender and depending on the house location. So we have 2 levels for the gender, and we have in this example 3 levels for house location: the metropolitan area, the suburbs, and the perimeter areas. So the combination of gender and house location identify 6 segments in the population, which correspond to the 6 possible combination of gender and house location. 2 genders, 3 house locations equals 6 segments. And the rest is exactly the same as before. We define this variable, let's say travel time in this example, for each of the segments. Okay? And this is the product of the travel time and the delta that identifies the membership of a segment. So each of these TT will be 0 for people who are not in the corresponding segment, and the value of the travel time for those who are in the segment. So this is the exact same specification as we saw before. The only difference that we have segmented the population based on 2 variables instead of 1. Well, of course, you can continue. You can base your segmentation of 3, 4, 5 variables. The problem is that then the number of segments will grow exponentially with the number of variables. And at some point, it will be too high. You will have too many parameters. And probably you will not have enough data in each of the segments in order to be able to identify the coefficients. So it may be useful to find another specification that captures the heterogeneity in a different way. At this point, we have investigated a lot of specifications that are linear in parameters. We were able to model quite complex phenomena. The fact that a variable can be generic or specific, and the fact that people have different tastes. So we have seen how to segment the population and to model the fact that different people with different types of socioeconomic characteristics have different taste parameters. This linear specification is extremely powerful, but sometimes we need to go beyond, and we need to calculate a model with a nonlinear specification. And this is what we will see in the next video. But before we do that, I suggest that you do some practice quiz to be more familiar with this specification.